Yeah, so should I start right now with the slides?
Yeah, you can start.
All right. So, well, again, hello. My name is Seredynski, and today I'll talk about cheats in mobile games and how the same cheats can be reused in regular apps. So we will start from a demo, and here you've got Among Us. So I'll show you how easy it is to actually, well, walk through the walls in multiplayer games. So let me just make it full screen. And here we are the red player in the center. And well, basically we just can't go through walls in Among Us, but I'll just show you how easy it is for hackers to do it. So the only thing that we actually need to do is to turn into a ghost. And once we are a ghost, we can like really go through the wall to the left. And yeah, once we're on the left side, we can just turn back into being an Among Us human and continue playing. So it's actually as easy as that. And I'll show you actually how it works later on during the presentation. And what's more, I'll also cover many other attack techniques. Like I'll show you how hackers bypass payments and Touch ID screens. I'll show you how people download paid apps for free, but also we'll cover, well, how people just unlock premium features in quite popular games and apps, and then how you can just get free diamonds in games with just like basic tools available online. But what's more, I'll just show you like 4 simple guidelines how to protect your app. So I'll just build like a secure model which consists of four elements, like environment integrity, application integrity, code integrity, and obfuscation. So throughout the whole presentation, I'll just build that model. And if you build it in your app, you can be sure that your app will be secure. So let's start from environment integrity. And well, I'll start actually from a demo. So if you don't care about environment integrity, that's what can happen to your app. So in that case, getting diamonds for free. So I'll show you it's based on Tamagotchi, which was, well, quite a popular app in 2020. I believe it was like in top 20 apps in App Store and maybe Google Play. And well, so let's open the app. And here you can see on the top that we have over like 1,400 diamonds. And well, the diamonds are, well, they are like premium currency. So you can buy like, well, premium content for it. So you can just buy like premium tools like clothing, skins for your Tamagotchi. Well, but you need to pay for that premium diamonds, and you can just buy them with euros or dollars, so just like a real currency. And well, I'll just show you that hackers don't really need to pay for that kind of stuff, and it's actually super easy to bypass. So the only thing that we need to do right now is just to exit the Tamagotchi. And right now we are opening a memory scanner. We open the memory scanner. We open the Tamagotchi app again. And once we have the app loaded, you can see a red gear here on the screen. Yeah, it's exactly here above the fridge. And well, once we tap on it, we will just open the memory scanner, and we can just scan for any number that we want to, well, find and modify in the game or app. So we will just type the number of diamonds that we have. We will just, well, scan the whole memory for those numbers. And as you can see, well, there are like a lot of numbers in the memory. So we just need to filter them out somehow. So let's buy something for 1 diamond, like sushi, for example. And then let's filter out those results again. And now we can see that there is only one place in the memory which has exactly the number of diamonds that we have right now. So we can just basically tap on it in that memory scanner, we can just modify that number to any number of our choice, like 777. And right now, the number of diamonds has changed, but the graphics of the game hasn't been refreshed yet. So let me close the app and open it again. So now like the whole game will just get refreshed and the graphics too. And well, once it's open, you will see on the top that the number of diamonds has changed into like 777, which was the number that we just modified. So it's as easy as that. We didn't really have to know we didn't need to have any hacking skills. We just basically used a tool that is available for everyone for free from like an online forum, and then we could easily modify the memory. So there's like a huge community behind the tool, and well, it's not only available for iOS, but there are like many similar for Android, probably even more for Android. And well, the tool has been already tested for like 400 plus top games in App Store, and it works. So it's kind of reliable. And yeah, what's important here, well, any cheats that I'm showing you during the presentation, they are available for iOS and Android. So it doesn't really matter which platform I'm showing right now. So one demo before I define what environment actually is. So that demo is about bypassing payments. And here we have another game that was quite popular in 2020. And in that game, we have like a lot of ads right now. Like here on the top left corner, we have that ad here. Then on the bottom, there is another ad. And in order to remove those ads, well, we need to pay. So once we tap on that button here, like with ads label crossed out, we will just see a pop-up. We'll just see a pop-up to pay for it. So I just tapped on that crossed ads, and we can see the pop-up. So it says we need to just pay to remove the ads. And well, obviously, hackers don't pay for that kind of stuff. And I'll just show you how easy it is to bypass it. So the only thing that we need to do is actually attach to the application and invoke a certain function. So inside that game, there is a function on transaction succeed, which is invoked after a successful transaction. So basically, we can attach to the game, and we can just invoke that function just from the command line like that without paying. So we just invoke that function right now. We invoked it. Well, so right now the game crashes, but we don't really care about it because, well, we invoked already the method. And right now you can see that there are like no ads anymore. So, well, we actually paid for it without paying. We just invoked a function that the transaction will succeed. So no ad here, no ad here. So basically we don't have ads anymore. So it's as simple as that. What's also important, the same technique can be used to bypass Touch ID screen. So if you keep any like sensitive information behind Touch ID screens, like in another activity or view controller, then, well, if you just limit the access there by Touch ID screen, that it's just not enough because you can just bypass it in that way. So let's talk right now about what environment integrity is. So it is about detecting a compromised environment. And the compromised environment is, for example, jailbroken or rooted device, or running an app or a game or the whole system inside an emulator, or just attaching a debugger. So if we don't implement environment integrity, people just can bypass the payments or authorization screens, but also they can spoof GPS, which is like quite a big threat in case of Pokemon Go. So basically there you compete with others to get faster to a Pokemon just to catch it. But if you can just spoof your GPS location, well, it's a bit unfair, and you'll just get the Pokemon faster than others. So if you just don't care of it, people will just cheat in your games. But well, it doesn't only apply to games, and I'll show it to you why later on. But what's more, you can just, well, cheat, like modify the number of credits that you have in a game or unlock premium content. But what's more scary, you can install like tweaks and tools on your device, like the memory scanner that I used. So, well, I didn't really need to know anything about hacking. I just opened the tool and just scanned for a variable, for a number, then just modified it, and that was all. So if we don't implement that one, it's super easy to actually cheat in our games and apps. And right now, I'll show you a couple of ideas how you can protect your app. And all of them are do it yourself. So firstly, on both platforms, you can just search for some artifacts like files on the file system, or you can just search for some applications. Like on iOS, it's like Cydia in most cases. On Android, it's Magisk. Also, you can just see the process properties on both platforms. You can also check if you're running on an emulator. So in case of emulator, well, you can check the name of a phone or of a device that you're running on. And if it contains emulator string, well, it means that we are probably running on an emulator. So that's the easiest way to actually detect it. So here you've got like a set of, well, in my view, the most practical ways to protect against environment integrity. For more ideas, you can go to OWASP MSTG. You can find probably more ideas like that. But in my view, those are the easiest to implement and the most like efficient. So yeah, implement them in your app to just, well, protect environment integrity. Okay, so now I'll talk about application integrity, which is just another component of our model. And well, so many hackers can, well, not hackers, actually, many users can install a paid app for free from third-party stores. So basically, there is not only one original App Store and original Google Play Store, there are alternatives, like, for example, iOS Guts. And here, well, you can download for free like paid apps. Like in case of Minecraft, you need to pay €8 for them in App Store. However, if you download them from iOS Guts store, you'll just get it for free. And well, it doesn't matter if it's iOS or Android, those stores exist for both platforms, so it doesn't really matter. And you can, well, actually you can download them just by clicking get and you'll just get it on your device. And what's more scary, those third-party stores, they generate revenue, but I'll talk more about it later on too. So how does it happen? Firstly, an attacker pays for an application, let's say in App Store, they install it on their device, then they dump IPA or APK or app from the device to the computer. And once they have the APA or APK file, they just distribute it online. I mean, they can just share it with friends. They can share it on an online forum. They can upload it to even the Google Drive, like anywhere, and just pass link to anyone. And then, well, it's already paid. So you can just take the APK file, install it on your device. So it's easy as that. But what's more, once you have the APK or IPA, you can just modify the content of your APK, of your app. So in case of Bomberman, well, the map is defined as a JSON file. So you can see the river on the left side, and the river is represented as number 174. So nothing stops us from just creating a huge G letter from river blocks in Bomberman. We just basically need to change the JSON file in a way that we have like huge G letter like that. So really easy to modify those resources. It's not only about maps, it's like a way more than that. So how it works, as I mentioned before, once we have an application dumped to our computer, we can just browse through the file, like the whole structure, and then find, like, for example, a JSON file for a map. And then we just go there, modify it, repackage the app, install it again, and then we have a new map. So we can modify resources, we can add new resources, but also we can inject new dynamic libraries. Like, for example, well, I told you about those stores that they have revenue. So they have revenue because basically they inject their own ads to paid games. So you can download a paid app for free, but you will have ads in there. But the revenue from ads doesn't go to the original manufacturer. It goes to those third-party stores. So they actually earn money on someone else's work. Okay, so now let's define what application integrity is. So it is about verifying if the user is running on our version of the app. So no resources are changed, and the app actually comes from the original, from the legitimate source, like App Store or Google Play, or at least from our link. And if we don't implement application integrity, then, well, people can just redistribute our app for free. So it can have built-in cheats, changed assets. Like in case of Duolingo, that is quite popular app where you can just, well, learn languages. And that app was actually hacked in a way that there were like new courses added. So the Duolingo is mostly about languages, but there is a version of Duolingo where you can just learn for a driving license. Well, so those hackers basically added, I don't know, like JSON file or just modified assets. And well, here you are, and here you have just, you know, another course in your app. Or if there is like any language missing, you can just add it easily. Also, what's quite important is that there is a common belief that you need to have a jailbroken or rooted device to actually run cracked apps, which is totally not true, because you can just repackage an application in a way that it allows you to attach a debugger. And once you can attach a debugger, then you can do all of the same stuff as you had like a compromised environment. So you can basically invoke functions or scan the memory as we did before. So make sure that you have application integrity, because, well, otherwise, well, you can just face the same issues as on a compromised environment, or well, your app can just be redistributed like those here. So a couple of do-it-yourselves. You can check for bundle ID of the certificate, or basically the signature of your app on both platforms. You can also check the JSON file. So like in case of Bomberman, you can just check if the hash of your JSON file hasn't changed. You can check for a debuggable state of your app if it's not being debugged right now, or if there is debuggable flag set in the manifest. So you can do all of that stuff in the runtime. And again, you can go to OWASP MSTG, find more ideas, but I believe that those three are like the basics, easy to implement, and they will really make your app way more secure. But anyway, recommend going to OWASP MSTG for more ideas. Okay, so now I'll talk about the third component of our model, and it is about unlocking premium content, so the code integrity. So once the app is redistributed in an alternative store, it often contains hacked features. Like in case of Plants vs. Zombies, it has unlimited coins, gems, and mints. Well, but it's not only about the game, but also it applies to apps like Duolingo. So in Duolingo, you can retake a test, I don't know, like 3 or 5 times. But if you download the version from an alternative store, it has already premium feature unlocked. So basically, you just don't need to pay for a subscription. And in a second, I'll just show you how it works. So basically, let's imagine that we have check license function, And here on the left side, the top left corner, you can see the developer's view. So it can be Swift code, Objective-C, and a high-level one. And here we just check license. We just have an argument license. Then we invoke validate license on server. We pass an argument. If the function returns true, we say, all right, the license is valid, and then we return. So from the hacker's perspective, it looks a bit different. So they can see only assembly or bytecode. But, well, so you don't need to know all of those instructions. It's just easy to spot where the if statement is. So whenever you see a branch in a graph like that, there is an if statement. So like that thing here, so like those two instructions happen exactly inside the closure. So we know that here is the body of the if statement, and TBZ is the last instruction executed. And here I've got like a small cheat sheet, and we can see that TBZ instruction just check for the return value of the last function, which was validate on license. We can see it here. So basically, we can check TVZ into TBNZ to just reverse the if statement, and then we'll just check if the return value is not 0. If we do that, and if we write the wrong license, then we will always succeed. So it's actually as easy as that. So that is code integrity, and it is about verifying if we are executing the identical code to what the developer wrote, which means that no machine or Java instructions were changed. So if we don't take care of it, then people can just unlock premium content in our apps like Duolingo or other games. We can have unlimited currency or bypass authorization screens. But what's more, well, we did a study in GuardScore. We just wanted to see what kind of cheats are the most popular in 25 top cracked games. And well, you can see that most of cheats were about infinite currencies, unlocked skins. And well, it's harmful for a developer because, well, people just don't pay for a premium currency. But there is also another category, like wall hacks or aimbots, where actually you can win with other players in a multiplayer game. So you actually ruin the game for others, which is, well, even worse for those gaming vendors. And that threat is really out there, and people really cheat like that. And the multiplayer thing is really scary right now. Okay, so how can you protect your app? Here, well, we have the check license function. And well, here we've got just assembly code of the function. And here, like on the left side, you can see opcode. So every instruction has an opcode, and we can just check. We can just create a hash out of those opcodes in the compile time, and then check them again in the runtime. And if they don't match, it means that, well, probably an instruction was changed. Like if we change it to TBNZ as we did before, the opcode would change, so the hash code wouldn't match. So that's how you can just verify it. So you can do the same with Java, I mean Android. You can just check for classes.dex, but also you can just check for swizzled method. And swizzled method is just a method for which the function pointer was changed. So if you invoked it, actually another function will be invoked. Well, it's actually a longer topic, so I encourage you to go to a blog post of my colleague and read more about it. It's quite interesting one and quite popular to use while developing new cheats. Okay, so now we'll talk about obfuscation. So, well, you remember the first demo during the presentation, how we walked through walls. So here is actually explanation why it worked. And it worked because the app didn't have symbol obfuscation. So symbol is actually name of a class or a function or a variable. And we were able to recover all the name of the classes and functions and so on from the app. And we found a class, player control. And here we had like several nice functions like die and revive. And well, we are curious what will happen if we just invoke die function from a terminal. And it turns out that you just turn into a ghost. And once you are a ghost, you can just, well, do whatever you really want. You can like go through the wall, for example. And once you are on the right side of the wall, you can just invoke revive, and then you are back human. You can just continue playing. So the plan of the attack was to find a relevant function, then invoke that function, and you can invoke it in many ways. So if you don't, well, if you have compromised environment, well, for example, you have a jailbroken device, you can just use Frida and invoke any function. Well, in case of application integrity, I mean, if you don't have application integrity implemented, then someone can repackage your app into being a debuggable app and then attach debugger and invoke function. If you don't have code integrity, then someone can just modify an app in a way that when you are close to the wall, you just invoke die method, then you can cross, and then once you are away from the wall, you just automatically invoke revive. So we used pretty similar technique in the second demo where we bypassed payments. So we found on transaction succeed, and well, we thought, well, probably that function happens after the successful transaction, and well, it actually did. So we just invoked that one. And you should really think about how many meaningful names you have in your app, because if they are like that meaningful, you can really, well, an attacker can easily find them and invoke them. Okay, so what is obfuscation? Obfuscation is about, well, making the code harder for an attacker to understand. So it's like renaming variables, classes, methods, encrypting strings, API points, but it's also about complicating the control flow graph. Like you remember the check license example. So you could just see on the graph where the if statement is. But we can use obfuscation to make the graph super complex to follow. So it would look like the one on the right-hand side here. So that's how the control flow obfuscation looks like. But what's more, you can encrypt assets. So for example, if you want to have a surprise for your users during Christmas, then you should make sure that you encrypt your assets. Otherwise, like, there will be like a cheater that would reveal those assets before you and will just distribute that app for free. What's more, well, people can, if you don't have obfuscation, people could just like steal your IP. Like, for example, you have a function that, well, prettifies an image that you have taken. Like you take a photo, then you prettify the image. And it's your just like own IP, in-house IP developed in-house. So an attacker could just take that function away from your app and implement in their app if you don't have obfuscation. If you do, then the function is dependable on many parts in the app. So it is really, really hard or almost impossible to get it from that app. But what's also quite interesting topic recently is auto-updating cheats. So auto-updating cheats are the cheats that can actually update on their own. So here you can see, let's say it's the first version of the game on the first screen, and a cheater like applied a patch, a mod to a game, and it's here, you can see it on the red. And then in the second version of the game, you add a new feature, like, and you can see it with the brighter gray color, but the patch can still be the same. Maybe code will be at the new offset, but the instructions around will be the same. So the patch will be applied based on the instructions around. So the patch, well, can be just applied in the same way. However, if we use compile time control for obfuscation, then each function is just spread away and shuffled with other instructions at the compile time. So even if an attacker patches your game now, then in the next release cycle, your app will look totally different. Like all of those pieces will be in totally different places. So the same patch won't work, and it will be also harder for an attacker to understand the code because those pieces are just like shuffled. Like there's like no coherent string here. So it is like resetting the clock for an attacker. All right, so how you can actually obfuscate your app? Well, basically.
Hi, Jan. Sorry for interrupting. I think 2 more minutes only we are having.
All right. Yeah, I'll try go fast through the slide.
Okay.
So basically, or you want to? I have just one more slide, I believe.
Oh, great.
That one. Cool. So basically, for the obfuscation, developers should write clean code, which is the opposite of the obfuscation. So the compilation time solution would be the best one. I'm not going to talk about those ways here. I'll just leave you slides for you later on, so we can just take it from here. And the key thing is just to implement all of them, all of the components, because if you don't, then it's just easy to bypass one component by exploiting the other one. So main thing here. And yeah, again, implement all of it. And well, regularly update your code so an attacker doesn't have enough time to understand your protection